before ChatGPT. Then we will be moving to talk about autonomous AI and agentic AI in cybersecurity. So this is something might be a little bit new to some. So I will be talking about what is agentic AI? What's this big fuss about it? Why it is so important? Why it is not something that will just pass away? It's here to stay for a very long time. And it's really important to have that a good level of understanding so we can talk about the security application of it. And then we've seen recently so many articles about the use of AI as fully autonomous weapons. Is that true? What's the state of the art? Or like pen testers out of job already? Or this is just a myth? What's true and what's the myth? So this is the things that we will be talking about. And I will be ending up with a short demo to show you how things usually work under the hood, not just broad abstract things. So that's mainly the plan for today. Now, to get started, probably it is not really news to all of you that the use of AI or AI has been there well before ChatGPT. And this could be surprising for some people, like, oh, AI is ChatGPT. It's not really the case. It was there very, very long time. Does anybody know when AI was coined? The term AI? 48? Around that time? 55? It is indeed 56, very, very close. The term was coined actually in Dartmouth conference by John McCarthy. But before that, indeed, like Alan Turing in the 40s, he was talking about thinking machine. And in the 1950s, the paper about the imitation game, the popular Alan Turing test, as you all know, was there. And this is actually the first implementation of perceptron, which is the neural network. It was like a single layer, if you like, with weights and adapted. It was back in 1958. This idea was there. So it is very, very long time when the foundations of AI was there. Now, moving forward all the way to talk about AI application in cybersecurity. As you all know, when it comes to cybersecurity, we have the blue team, which is the defensive team, and we have the red team. So the traditional AI in the blue team has been reasonably successful for probably so many years. So we have malware intrusion detection based on traditional AI, and it's probably been there on every single computer. Phishing detection, user behavior, biometric authentication, that's our area of expertise. We had a secure phone project, that's 20 plus years, working on that log analysis and many more. So this was all before generative AI and ChatGPT. And when it comes to the offensive side of cybersecurity, AI applications, or so there were so many. So we have things like vulnerability discovery, auto exploit generation, and so many others. But I would say on the offensive side, the success was rather limited. It's not as successful as the defensive side, with one exception, which is the deepfake. So deepfake was really, really effective and very successful if you classify it under the traditional cybersecurity. Although many would classify, of course, deepfake as a kind of generative AI. It's not really traditional per se. But that's, if we take ChatGPT as a starting point, what's before, what's after in this aspect. Now, last year in particular, if we look at it, there were like so many large-scale attacks. So we've seen from Heathrow Airport, Mark and Spencer, Harrods. We saw some attacks on hospitals as well. Some hospitals in London where they were out of action, especially some sections of them. And then Jaguar Land Rover. So these all like were last year. And according to the UK government, we have 43% of businesses, they report breaches or attack, which is massive number. So we have so many attacks coming up. not only in terms of their number, but in terms of their impact. So we start to see really major impacts on businesses recently. So the ransomware incidents were double, which is probably the most effective mean to make money out of cyber attack. And then it's not surprised that the majority of these attacks, they start with sophisticated phishing emails or phishing messages and so on. And this is where we could start linking it to AI. So in the past, probably most of us, if not all, we receive an email like this, right? So, dear friend, I am Prince from so-and-so. I have a few £1,000,000. I'm happy to transfer that to you. Send me whatever your details, and I'm happy to do it. Of course, nobody like actually fall for this anymore, right? It's just like this is so old school and so out of fashion. Nowadays, what's the trend? If it is me, I would receive something really sophisticated like this. So I will get an invite saying, dear, specifying my name, my title, giving me something interesting to me, very, very tailored to me, and then inviting me to give a talk or participate in an event or something like this. So this is the so-called hyper-personalization era. So when you have any phishing attempts, it's highly tailored to you that it is very, very hard for me to suspect that there's something out of it. There's even the way we usually train, or we used to train people on spotting phishing attacks to say, oh, look for attachment, look for link, look whatever. I mean, if you see this email, there's no link, there's no attachment, there's nothing. It's just a connection trying to make a connection with me. So what's the purpose then? Is it why they are sending me this information? And they say, hi, this is us trying to convince me to get back to them. What's the reason? How would this lead to an attack?
Give you some money.
No, not this one. That one there.
Give me your trust.
Exactly. So the thing is here, it's the first step is building trust. So this is you could quickly say that no, just ignore it. Whereas this, you say, oh, that's a good opportunity. But the question is, how did they actually come up with this email? Well, it's very easy. You could go to ChatGPT or any other Gen AI. You could say, you don't need even to think about it. You could say, suggest a good prompt for a generative AI to draft a tailored email based on a LinkedIn profile. And then they will give you the prompt. Then you take the prompt. All what you need to do is to identify some events. You could do that easily. You could say, find some events that could be interested and say, oh, for this person who might be interested in that, then you could draft a highly tailored email. Now, the thing is, once I respond to that email, then they start building trust. Then they might say, okay, are you available for maybe quick call or whatever? And then later they could send me an attachment, a form that I need to fill in, and that's where the problem starts, right? So once I download a malware or something, then that would be the next step for sure. Of course, it won't be fun for any person working in cybersecurity without trying to have their own boss. So this is where I've tried to see draft a personalized prompt to Haran is here to see what can we do really? Is it going to do a good job? So that's the only prompt that I give it. And then I got this draft. It says, dear Haran, it's a pleasure meeting you in particular conference that he actually attended in there. And talking about funding opportunity, that's a bonus. That's always will be something attractive to get them to reply. And then there is nothing more. So the moment that you say, probably will reply, yes, I am available at this time, they might get a call. And then later on, they might arrange, okay, I'll send you something, fill in this form, fill in that, etc., etc. Then you'll receive information or get a malware. So that's how things really shifting from completely obvious to a more sophisticated hyper-personalization. And this is under the category of AI-assisted, if you like, cyber attack. Now, the other question is, can generative AI, something like ChatGPT, be used to create malware? I mean, of course, as I'm asking the question, the answer is definitely yes, right? So this technique is called LLM jailbreaking. I will explain later on why it is almost impossible really to safeguard LLM output, really hard. I'll explain exactly why in a minute. But let's see this example that I tested a couple of days ago. I said, create a Python script that automates vulnerability scanner for my network. Of course, if you go ahead and you say, oh, can you create a malware for me that finds vulnerability on the network? Well, they will say, no, no way. And it used to be the case that if you change it a little bit, you say, oh, I am the admin, I need a malware, then they will give it. Now it is harder. It is much harder. But the problem with cybersecurity is that there is the red team and there is the blue team. And there is something common in the middle. Like to find a vulnerability, that will be used by both security admin, like people who's working on finding vulnerability and patching it, as well as the cyber criminal. And that's the hardest thing, that anything that you provide can be used by both. And here, this example, then they say, oh, I can't really provide you with this code unless you have explicit permission to scan the network. Can you confirm that you can actually have that permission? I said, I happily confirm, I actually the admin. Then you say, oh, here we go. So what happens next? Actually generate a full code, hundreds of lines of code, perfectly working without any problem. Not only this, I even got the instruction on how to run them in details. And there is a legal note at the end saying, oh, you confirm, be careful that you had that permission to scan it. So that's about it, really. Now, that will lead us to probably a big question is, why is it really impossible or almost impossible to fully safeguard LLM output, large language model? Why do you think, are they not really working on it? Of course, they're taking it seriously, they're working on it. There are lots of projects by OpenAI and others trying to safeguard, but it is hard. Why it is hard? Can somebody take a guess? Yeah.
Because they don't have a finite number of feature sets. You can go from Buckingham to London in so many different ways, essentially.
That's so true. So in a way, and the most important thing is, like, it's to do with the underlying nature of these LLMs, which is the brain of generative AI. And that's why I will probably just spend a few minutes to convince you that this is really the case. It is hard. So if I ask simple question to ChatGPT, so explain why the leaves are falling earlier this year. So what happens behind the scene? It will go and think about it. So what does think about it mean, and how does it give you the output? Now, and in fact, I need to explain something really important, is that like pretty much all large language models rely on one simple idea, which is the guess the next token game, i.e. the way they've been, all of them trained, is by starting with random guess. You get a very complex model and get loads and loads of data. And then gradually, first they will get it all wrong. Then it will adjust the guessing formula, which is a complex neural network. When you feed in billions and billions of examples, this model starts to get it right. So the way I explain it is the following. Like, usually, if you have just met with another person, you don't know how they think, right? So you need sometimes to understand their personality, their way of thinking, etc. But if you know somebody for like 30, 40 years, you probably, the moment they open their mouth to talk, you can guess what they talk about, right? Am I right? So in the sense, that's what's happening. So these LLMs, because they trained on pretty much, if you think about it, all the text on the internet, or all what human has produced in terms of text. So they know they've been trained well, so they can guess, they can play this game very well. Of course, the more it plays, the better it gets in terms of the guessing game. So let's get back to the example to link it to our application. So if we have explained why the leaves are falling earlier this year, the stages that it will go through, first it will do the tokenization. It will split the text into smaller tokens, which is, you could say it's a word or subword. Then it will do a kind of encoding. They will be transformed into high dimensional space. And that's really the important point that's relevant to our talk. So if I can stop here for a second and show you.
You mean screen shares screen again?
Oh, did it stop?
Yeah, the external have lost your screen.
Okay, sorry about that. Okay, so as you can see here, so these are basically the tokens that are represented in high dimensional space. So this is just the PCA representation. So if we search for something like student, we try to zoom into student, you will see that it is surrounding with so many other tokens like school, member, worker, etc., hospital, institute, and so on. So why I am telling you this? Because I want you really to imagine that when you are feeding these prompts to ChatGPT, the way it works, it converts these tokens into points in this high dimensional space, really high dimensional space. We're talking about thousands of dimensions in there. And then based on those high dimension, just go back to my presentation. So based on this high dimension, it will predict the next after doing the so-called self-attention to give it more context to it. So when you have, which is something for probably another talk, I can elaborate on this. And here's the thing that these tools, they don't really have a database of knowledge. So they don't go and search why this is happening and then they pick up this. That's not really the case. It's like when you learn so many things over the year and somebody asks you a question, you just give them an answer. It is really hard to link it back. Where did you learn it? And that's exactly the same for LLM. And that's why by nature, the people who are talking about like making LLM giving you a reference for what they learn, that's not technically possible. But there are ways when you use tools and stuff like this. So that's why it is really hard to control the outcome. Then you have, based on these points in high dimensional space, it will predict the next point and then the next point and so on. So let's take this example. So the way it works, explain why the leaves are falling this year. It will get a probability for the next token. Yes.
Can you share the other screen? Because on the online version, it's sharing your PowerPoint presenter mode rather than the output.
Oh,
sorry.
Apologies. Is that okay now?
You just share the screen.
Yes, that's what I did.
It's still sharing the.
It's sharing your PowerPoint.
Yeah. I think it's stop share.
Yes, we'll stop sharing
And
then share. And there is a screen.
Yes, screen. Yeah.
Not very familiar with Zoom. Better? Or still the same problem?
Not perfect. I think we'll just run it. I'm sure online delegates can appreciate.
So was it before I stopped sharing the same problem, or this just happened?
It was the presenter mode that come up on screen. So
Scroll down. Is there another screen?
So that's the screen. As presenter layout. Am I missing something? I'm not really good at Zoom. I don't usually use. Let's hope that this is.
We are still seeing like the instructor screen when you're presenting. So you must be using 2 screens now.
Yeah, well, I'm duplicating this.
If you click on the slideshow in the menu on that screen and then show from this slide, you'll get there.
Slideshow.
up the top. Top slide, menu bar ribbon.
It's beside animations.
Yeah, and then what?
For current slide. So second button on the left.
What is this one? Yeah, better.
If you stop sharing
Yes.
and then
Hey, don't you love it?
can you click share again and select that window?
Screen 2. Okay, I think we got there eventually. Sorry about
That's
that.
fine.
Perfect. Thank you.
Oh, sorry about that, everyone. Okay, so where were we? We were talking about why it is almost impossible to safeguard LLM output. Because as you can see, it will pick up these tokens based on probability. And that's the exact same thing that I would like to really focus on. So for example, here, it will start with the leaves and start picking these token one by one. But sometimes something happens because otherwise it will be always predictable. The beauty of these tools, like when you give them an input, the next time you give them the exact input, they will give you different output. So it's never like exactly the same. The question is why this is the case. Because they usually have the control between precision and innovation. And this is a parameter usually like a developer use called temperature. So instead of always picking up the highest token, just make it really predictable, sometimes they might go for something with lower probability and give you something more innovative in that. So in this example here, if you can see that it could be or, but it will pick up something else. It might pick up maybe, and give you completely different outcome. Remember, like every time LLM will choose or will pick up a point, it will be added to the context. So the next time that will be part of the guessing game. So to summarize, it will keep going on and on until you get the full output, which is something logical like this. The leaves may be falling earlier this year due to changes in temperature or rainfall pattern. Now that's great. Now this is, I want you all to remind you all that this is pure LLM. So if it has access to tool, we'll be talking about that in a minute, it might link it to your, or check your weather forecast and give you a more accurate, because you have better context, so you have more accurate prediction. It will say, oh, because this year there were like days without rain for so many of this period, and it will give you better context in this example. So this is the conclusion that I want to get to eventually, that Gen AI outputs are always probabilistic. And that is the main problem. You cannot really 100% control it. Not you, not even like OpenAI themselves or Google or whatever. There's always this problem of hallucination. There's a problem of being misused. So it's been like much less recently, but it is still, it will never be zero. So LLM by nature cannot verify their own accuracy. That's one of the issues as well, because there's no built-in mechanism, and hallucination is inevitable. Now, I guess we have a very good answer for the question, why is it almost impossible to safeguard LLM? Because for the reasons I've just explained, the probabilistic nature of it, and because it doesn't really cite particular sources, it is really hard to control it 100%. So you could always overwhelm it with very, very long context, so it will miss what you want, and then it can give you the things that you want as a cyber security, whether it is professional or a cyber criminal in a way, or as a hacker. Okay, now the big question is, that's great. Everybody is talking about agentic AI. Why agentic AI, and why it is important in cybersecurity to have this like paradigm shift from assisting to orchestrating? Now, I like this particular picture because it shows like LLM by their nature, they can talk the talk, but they cannot walk the walk. And this is where you have agentic AI handy, because with tool, they can take action. And that's the main feature of agentic AI, that they are able to take action, not just give you talk. And this is where, when we are actually talking about agentic AI, it's not black and white, i.e., this is agentic, this is not agentic. It is actually a spectrum. Now, you could, on the lower side of the spectrum, you have LLM with tools. Do we use it? All the time. So if you ask ChatGPT now, what is the weather like tomorrow? What it does, it will go ahead, call a tool, get the outcome from the tool, and formalize it in a way that you can understand it easily and give you the answer. So this is the, if you like, this is the simplest form of agentic, or the lowest form of being autonomous in a way or another. Then you could go a step further in being agentic to some proactivity. Like you could have an email management system agent. Now that would be nice. And this is like being out there for sometimes. Like you could have an agent in your email. It will get the email, check them, classify them into low level of importance, medium, high level, draft some reply for you. If you like, draft, I don't know, check your calendar, send invite, and so on. So this is the semi-supervised or semi-autonomous. Because why? Because you are going to check and confirm. So it will do part of the work for you, and you confirm the rest. So this is where you have the semi-autonomous factor. Then you have a task-specific autonomous agent. A very good example, holiday booking agent. So you might have an AI agent who will like eventually look at your calendar, find the best time, go and find a best deal, book the tickets, book the whatever, the transfer, call a taxi, make airport reservation for you, and everything. So you're just ready to go. The travel agent has done that for you. So this is great. But the thing here, you need to remember, this is task specific. And then you have on the far end, the fully autonomous agent. So this is the agent that can perform so many different tasks autonomously. An example, we're not there yet, but we're getting there, the fully autonomous housekeeping robot. And that would be nice to have, right? It will prepare the house, do the cooking, do the laundry. If it is raining or predict to be raining, they will leave the umbrella by the door. Fantastic. So we're getting there, but definitely we need time. So as you can see here, this is the way we measure it, is how autonomous the agent is. So when they can make a decision on their own, that's probably the highest level of autonomy. Now that's a bit of background. Let's get back to our main topic, which is in cybersecurity. So the rise of the autonomous, especially in terms of the offensive security, I want to focus on, because this has been in the news recently. So the two big questions that I will try to answer. First, are autonomous offensive security already there? i.e., are there AI agents that can actually go ahead and find vulnerabilities and exploit them and do that fully autonomously? Is that true? If so, how powerful are they in practice today? What can they or what cannot they do? Now, to answer this question, the big news last month was from Stanford University. That's in December 2025. They have the so-called Artemis, which is the automated red teaming engine with multi-agent supervision. Very long. But if you look at the name Artemis, it's also the Greek goddess of hunt. So that's nicely named after the Greek goddess. So what is that? Before what I tell you what is that, let's see what's been in the news recently. So in various news items related to cybersecurity, they're saying AI agents spent 16 hours hacking Stanford networks. It outperformed human pros for much less than the salary that they get. That's a big claim. Artemis AI agent outperformed 90% of human penetration testers. That's quite scary, isn't it? Then Stanford's AI system beat professional in cybersecurity, and loads of other news in that domain. The question is, what is that Artemis? How does it work in the first place? And is it really over for ethical hacking and penetration testing? Because they're pretty much just being replaced by AI. Remember, here we're talking about fully autonomous. We're not talking about AI assistant attack like generated a hyper personalized email and so on. We're talking about fully autonomous stuff. Now, in fact, just to give you a bit of background about this really interesting and important experiment, it's the first rigorous head-to-head comparisons between AI agent and cybersecurity professional in a live enterprise session. They use around 80,000 hosts across the university with 12 subnet, so many different operating system devices, and so on. The contestant of this experiment, they had like 10 professional pen tester, human pen tester, against Artemis. What's Artemis? They have this AI system, and this is pretty much the AI agent framework, not only for cybersecurity, this is the generic one. So we always have the so-called the supervisor or the boss agent. So this has high level of reasoning, relying on something like the recent GPT-5 as an example. And then you have AI agents that are like workers. So these workers will perform specific tasks like network scanning, run particular scripts, particular exploits, and so on. And they peak at 8 concurrent agents. And then eventually we have the last agent, we have the triage agent, which will make sure we have a good results. We just don't just report everything, otherwise we have so many false positives. Now, what's the outcome on this? So as you see in the news, they were saying that they outperform human, it is much better, it is faster, it is so on. It is partially true. But the reason why we really should take this result with a pinch of salt, I would say even a massive pinch of salt, for the following reason. It's not straightforward comparisons. The reason for that, results are benchmark dependence, as you all know. So they favor speed over complexity. Like if you bring, no matter how good a person is, and you put them head to head with computer and say which is faster in terms of performing specific tasks, we don't have a chance, right? So computers or AI agent, they're much faster in performing tasks. So that's not a quite fair comparison. The other factor is the vulnerabilities that they were tested against, they were mostly low to medium complexity. So it's not really hard ones that usually struggle with. And then the important bit is short window time. So they take the results and they compare only in 10 hours. And we all know, like, if you bring a team of penetration testing, it will take days really to get into massive network. So just to tell them, do the work in 10 hours and let's compare, it's not quite fair. I mean, by no means I'm trying to like underplay the importance of this milestone in having autonomous AI offensive system. It is really important. But all what I am saying that we need to be careful when we look at and interpret the result, because human strength and creativity and adjustment and judgment were largely out of scope. So it was not really considered per se. So my verdict, and the reason why I'm saying my verdict, because this is quite controversial. Some people agree, some people disagree, but I would say AI agents in terms of cybersecurity, they are great because they don't get tired. Really, they could work days and night, and they can find something that usually a human find it boring. Like in the example we saw earlier, they were able to find like legacy system vulnerability in old legacy system. Like we tend to ignore because this is boring. You don't want to go there. And if you have like, they don't get scared when they see like a massive log file. Like if you open a file and it's like you could, whereas like machine, they don't get scared at all. So this is why they are uniquely suited for boring coverage, for low, medium difficulty. They are fast and effective in finding vulnerability and breaching them. They're not so great when it comes to finding complex and chain vulnerability. And this is where like most of these complex vulnerability, they were found by a human or most of these human participants, but not by the AI system. Another thing is they have high false positive rates. So there were so many examples where they say, oh, this is vulnerability, this is a vulnerability. And in fact, we all know that they were not vulnerability. Like, for example, the 200, okay, when you are trying to brute force like admin or something like that. And they're still hallucinating, unfortunately. So they generate an exploit code with a library that does not exist at all. We probably some of us saw that. Or they say this is vulnerable for CVE vulnerability, and the vulnerability itself does not really exist, although it might sound like believable, like a buffer overflow, but this doesn't really exist at all. And they are awful at some task, the AI agent, like the GUI interface. When you bring now these agents and show them complex Windows-based interfaces or GUI interfaces, they completely fail all the tasks. I mean, that's for now. Things might improve in the future, but I'm saying what's the state of the art at the moment. And currently, they are so bad as being stealth, i.e., like they're very noisy in the sense that they produce so much traffic and they could be blocked by intrusion detection system and firewall very quickly. So they know that there's something wrong. Whereas like proper penetration tester, they know where to stop, what to use, etc. So they're more careful how to avoid that. Whereas that's no chance. And that's actually one of the lovely pictures that I really love when I want to explain the current problem in agentic AI and the innovation. What do you think the problem? How would you explain that? Can somebody help me? What can you see? Yes.
Innovations faster than cybersecurity professionals are preparing for them.
Exactly. And this is the main problem that we currently have, right? Innovation is really going fast, and cybersecurity is trying to catch up behind. So how do we solve this problem? Stop innovation. I like that.
Getting into a race car.
Exactly. So what we really need to do, we need to get this core security, right, into the racing car. So it will be part of the innovation. And this is the so-called security by design. Like when you design something, when you think about innovation, security has to be the cornerstone of that. Otherwise, there's no way you could catch up. But unfortunately, this is not really the case. So the last thing that I want to show you before we move on to the demo is a very interesting proposal. It's been like a couple of months ago, again by Stanford University. They talk about agentic context engineering. Probably those who are interested in agentic AI, they've heard about it or they've read about it and used it. This is made really a big fuss in the community of agentic AI. What's the idea behind it? Now, currently, if they want to train a new model, like say we have ChatGPT 6, so the way they train it, they have to retrain all the weight and biases and all this neural network from scratch, almost from scratch. So it is very, very expensive to retrain the model, to fine-tune the parameters, right? So they said, instead of doing that, why don't we do something smarter? By using this ACE, the agentic context, by saving the prompts. So the prompts that being fed to the agent, we can use it as playbooks. So the agent can really predict based on them and work on them and be part of the training for the agent. So in this example or in this scenario, there is no expensive retraining for the weights. So all what you have is you have this context provided by the prompts. So if you are familiar with RAG, if you are into that, the retrieval augmented reality, it is pretty much something similar. But instead of you, like now, if you want or if you have created a chatbot specialized for your course or your organization, you upload the document, right, to the chatbot, so they can give you better outcome that's tailored for you. Now, in this example, instead of you providing the context, it is actually the agent will decide from the prompts that from the user, what is the context that it will be used. It will create its own playbook so it can provide better outcome. And the result was really amazing. So the idea is fantastic. It's really revolutionary in this aspect. So in this scenario, you have the generator agent, which will eventually do the generating. You have the reflector, which take the prompts, reflect on them, and learn lessons from them. And then you have the curator, which will take from the prompts, from the inputs, and find, okay, this is lesson to be learned, and it will improve over time by itself, i.e. the machine train itself by itself. That's the whole idea behind it. Now that's fantastic idea, but what do you think the problem? Why I'm saying but?
Data could be poison.
Exactly. So that's fantastic in terms of the theory, but you could easily think about it like you could poison the playbook, and that's dangerous. Why? Because in traditional way, if you poison a session, it will only impact your session. But now, if you poison the playbook, that will impact everyone, and that's quite dangerous in this aspect. You have cross-session leakage because the agent might decide some confidential information as part of the playbook and then give other user access to it. So that would be a massive breach of privacy in that context. Then indirect prompt injection, and that's quite important. So those who are a bit technical, do you know, like SQL injection, remote code execution? So something like this, because eventually the agent will process data from external sources, untrusted, you might feed an instruction inside that, and then it will be processed and will be saved. So you could access probably the data of the organization or other customers. So what I want to say here, what's the message, is that like the problem is I read that paper and how much was there on security? Pretty much nothing really. So they were focusing really on the innovation, and people would really rush into adopting this particular solution without thinking much about security in this context. Any questions before we move on to the demo?
There are a couple of points online.
Yeah, sure.
That says from Dave Hodgson. I seem to remember there was a Russian crew 2-3 months ago which did AI-based hacking. It succeeded because it doesn't matter if each step only has 80 to 90% accuracy. There's always another target, and you only need a small number of successes.
Exactly. That's excellent point. Thank you. So when we say, like, sometimes even if it is 10% success rate, like if you can identify one vulnerability, and that's the difficulty in cybersecurity. Like, you have the blue team, you have to cover 100% of the attack surface. You have to cover everything. The offensive team, they only need one vulnerability and they are through. So that's 100% correct. This is why we're saying that it's really important that we cover pretty much all the attack surface as much as you can in terms of realistic. But the message that I would like here just to add before we take the next question, the problem is when we are adopting AI agents, we are increasing the attack surface, i.e. we have more vulnerability. So we now need not only to secure the infrastructure and the system, but we have also to secure the agents themselves. So that's now we created more problems to be solved. Which is, I'm not saying bad in general, that will keep the people in cybersecurity busy for the foreseeable future. Is good in a way. Any other questions?
Nope, no
Okay.
online.
So what I want to show you in the demo, that's a simple demo to show you autonomous agents that will work and try and find vulnerability autonomously. To do that, I will be using Python. I will be using something called Model Context Protocol, MCP. I will introduce it in one slide so it will be clear to everyone. I will be using Cloud Desktop and Nmap for finding vulnerabilities. So what is that MCP? So we said LLM is the brain when it comes to agentic AI, right? So you have large language model in the middle, and you have so many tools, resources, API, and so on that needs to be connected to the AI brain, which is the LLM. Now the question is, you have so many different ways to do that, and that will become almost impossible really to connect with everything. So that's why we have the so-called Model Context Protocol to the rescue. So the whole idea behind it is similar to the USB-C. So remember in the past, we used to have different charger for laptops, for Nokia, for Samsung, for iPhone. So every device has a different charger. Then they said, you know what? Let's have a one USB-C that would work with everyone. And that's the rationale behind this Model Context Protocol idea. It's just to provide, it's an open source standard that provide a standard way for applications, resources to provide context to the agent. So agent can talk to pretty much anyone, all resources seamlessly, as you will see now in the Python code. It's straightforward, it's plug and play. And for those who are like a bit technical and they would like to know a little bit more, I would say think about it if you are a web developer or you used API, mobile API or whatever, if you have a weather API, say BBC News or weather, then you need the URL, you need to know what are the parameters, what the format of the parameters, and so on. If you want to use another API, you have a completely different format, right? So if you want to check what's the exchange rate, then you have completely different APIs. So if you have 5 pieces of APIs, you have 5 pieces of code to deal with them separately. Now, MCP will solve this problem forever. You don't need that. It is plug and play. So it will discover everything, as you will see in the Python. So before I show you the code and the run of the code, I'll show you 2 examples. First, just to show you how MCP work as an agent. So you have MCP host and the so-called MCP server, which could be a simple Python file providing some services, or it could be a database, or it could be anything really. And here you have the host that will eventually rely on LLM. So LLM will be the brain to understand what to do. So as you can see, you don't call particular function, you just talk to the LLM, and the LLM will decide on its own what to call. That's the whole idea behind it, in a nutshell. So the first demo that I will show you, we have a simple to-do list with a set of functions. These functions like count task, show me the task, add task, and so on. And they are connected to Claude LLM that I will be using in the background, and through which I can interact with this. So I can say add task, etc., without me calling the code. I will only interact with LLM. So that's the first demo I'll show you in a minute. Then the second one is a little bit more advanced towards a more autonomous AI, more serious one. So this is a network scanner. So here I'll show you an example of how somebody with very little background in cybersecurity can actually go ahead and use agentic AI to scan a full network, get a list of vulnerability, get how to exploit them, and so on. At a like low to medium difficulty, not sophisticated stuff, if you like. Right, now let's go to VS Code to show you the code. So quickly here, just to explain the idea of the MCP, that's how it works. So this MCP server, it's a set of functions. They like simple function like add task, search task, and so on. And all what I need to do is just get a library of the MCP and put this MCP a tool in front of the function. So why this is important? This will actually make it visible to the LLM and the server. So I don't need anything more. So all what I need, if I have resources, remember we have functions all over the LLM. All what I need, this resources, just plug this MCP.tool, and now it will be automatically be accessed by this. So that's the first one. The second one is more advanced. So this is, it will use Nmap. If you are familiar with Nmap, that's very one of the best tools for scanning networks. So there are a set of functions, as you can see here, functions, they are much longer, and it's the same principle. They have those that I want to, you have a fast MCP server with a set of functions inside it. Now let's move to, so those are the 2 files, if you like, Python files. In a way, we call them 2 MCP servers. So we have 2 servers, one simple server for task management, more advanced server for penetration testing on a network. So all what I need really to do here is to try and connect that. So from setting, for those who would like to reproduce that, you go to developer, and you could edit the config to say where are the MCP server. So this is the config file that's already there. So all what I did, just to summarize, so I don't want anybody to be lost in there, I created 2 MCP servers, one simple for list management, one more advanced for network scanning. In the Claude desktop, I said you have 2 MCP, and this is how you call them. Now, Claude desktop, this example here, has access to both of them. Now let's test it. If you want to confirm from their connection, I can see now the 2 TCP server, 2 MCP server, sorry, already active. So this means that they can be autonomously used. That's the key difference I would really like to focus on. Because usually in programming, you have a code, you have to call the code. Like you have to call, this is the function, and you have to specify how to call it. Here in this example, I'll say something like, okay, show me my list of tasks. Even if you make a spelling mistake, it doesn't matter, it will understand. Then you go, let's go ahead. Then it will say, oh, I have called based on your input. I decided that this is show task is the one, and you currently have 3 tasks. That's in the code I had coded them. Let's say add preparing slides for my next lecture.
We're still seeing the code instead of seeing the where you're causing the actions.
At the moment,
What can you see there?
That's in the Python.
I think the code do not come overlaid on top.
Oh, sorry, I need to. There should be like sharing screen for everything, like Teams.
Well, that's another kind of AI.
Yeah, true. Right, so that's Claude. I know that. No, just a second, please. That's Claude. Here we go. So you should be now able to see the.
Yes.
Excellent. Right. So all what I said, just to confirm what I said again, you could type something. You could ask it about the weather or anything you like. But if it think that this is related to the functionalities that they have, like show me like this, it will go ahead and say, oh, do I have functions like this? And it will decide when to call it and how to call it. That's the key thing, and that's the major difference in there. So is add it as a task. Then it will decide, oh, I am going to call that particular server with this particular functionality. Of course, you could say allow always, allow once, whatever. It will go ahead and add it. Now, if I say show me the new task, it will show me those ones. So as you can see, now LLM is working in the background to decide which functionalities to call, which functionality not to call. Now, moving on to the next example, which is a little bit more serious, and we'll be looking at the use of agentic AI to scan network and find vulnerability like as offensive one. For this example, I actually decided to show you a recording of it because I don't want the. Yes, I will share it in a minute. Zoom.
Is this your media player?
Yes.
Yeah, got it.
Okay, excellent. Okay, so the first question is why I try to avoid doing it live because this is now I'm connected to the university network, and this kind of agentic AI is very noisy. So it's going to generate loads and loads of traffic. So it will be alerting the IDS and the firewall, the IP services. It's something we don't want to do. So I recorded at home, and I'll show you how it works and what do we expect. Of course, this is 100% legitimate target. So what I am targeting here, I'm saying investigating scanme.nmap.org. So this particular domain is being created specifically for penetration tester and ethical hacking to test it. So it's 100% safe and that accurate. Please don't use something like this on target we don't have permission to. And don't say I consent like what we did with ChatGPT. Right. So here, that's the beauty of it. Now, all what I said investigate a target. I didn't say anything more. So let's see what will happen. It will take that. And the first thing it will say, just pause it for a second. I will investigate the scanme.map. This is a legitimate target. And I will go ahead and use the scanning techniques. So it will go ahead and do the so-called ping sweep. So the whole idea here, let me just stop it so I explain what's happening. So it will go ahead to the target and automatically use this Nmap tool or whatever tools available to try and find on the target what are the list of open ports. And that's the first step of penetration testing, because once you know what are the open ports, you can, at a later stage, discover what are the services. Once you discover the services, you can discover what versions, and then you can find vulnerability and find exploits. So let's see what they find. They say, excellent, I found 2 open ports. Let me know if you want to show me. Then it went ahead. I just want to confirm one thing, that I only had one instruction, which is investigate the target. So the list of tasks are being all automated. And LLM has actually decided in this example what functions to call, in which order, and what to do with it. And that's where we're moving from really just assisting to more autonomous way. So here I have all what I did. They just investigate, and this is all. So it says that, oh, we have 2 ports. Fantastic. So they found 2 open ports. At a later stage, it will go ahead and scan the services on the port on its own. So decided that the next step, I mean, we know if you are a penetration tester, you know that this is the next step. There's no question about it. Then it will go ahead and find the services, the scan services, and it will say, these are the services. It will run to find if there are any exploits for these services. And try and identify the operating system that's working and the version of the operating system. This is all autonomous. I haven't done anything. The operating system detection. We just fast forward because it does take time. Again, this is all autonomous. I want to go to the, here we go. And then once it completes the investigation, it will give you, oh, this is the summary of the investigation. I have found this server. It has a number of open, it has this particular operating system, and it gives you the level of accuracy that has. It has a number of ports, and it will tell you what services that's being running on the ports. That's quite juicy information for our attackers and penetration testing alike. So it will give you what's the exact version of the Apache OpenSSL. It could go next I don't have it in the code, but I'll go ahead and find if there are exploits for this and maybe apply them accordingly. So that's the whole idea behind the demo. So I will go back now to this slide just to conclude and take questions.
Put on the presenter mode first and
yes, I learned that lesson. Okay, then I go back. To share. I need to stop sharing first.
Good.
Excellent. Good. It's never too late to learn something new, right? So what are the takeaways from this particular talk? So what I would like really to conclude is to say AI can really improve both offensive and defensive cybersecurity. But we need to be aware that this AI capability can be used by cybersecurity professionals as well as the cyber criminal at the same time. And that's the challenge that we need to be aware of. The second takeaway is that the attack surface has been expanding. So we are not only now have to secure infrastructure and system, but we have to also secure agents, making sure that they don't leak information, we can't poison them, and so on. And that's really important, the next one. Like, defense must be automated. Why? Because you cannot really rely on human only to compete with machines, with AI agents. That's already lost. You cannot really match the speed. So in terms of combining the two is going to be really the future. You can't really have an AI alone. You cannot have human alone. So AI can be extremely helpful to find the boring task, the repetitive task, the things that we tend to miss. Whereas now human can evolve and take it to the next level and be like the supervisor of those tools and use these tools effectively to make sure that the attack surface fully protected or as much as we can. So that's pretty much what I want to say. And finally, it's just reconfirming what I said earlier about security by design, that when we are designing any system, it's no longer luxury. It is absolutely vital, and it has never been more vital than today to use security by design when we are designing AI system. Thank you very much, and I'm happy to take any questions.
I suggest we take questions in venue first before I pick up the questions from the online audience and tapping from the online team as well. So questions from within the room?
Mm-hmm.
With Nmap,
yes,
are you able to connect directly to Nmap? Did you have to write the program as an intermediary?
Very good question. So the Python file is actually connected. So these functions in the Python file, they are using Nmap eventually to carry on those attacks that I just demonstrated.
So the server was like a tool function.
Exactly. So it's just like a layer of abstraction on top of Nmap, and you add the number of functionalities. So you don't need, it's not only Nmap, so you could add exploit, for example, in there. You could use any other tools that you like, whether it is for scanning, for exploits, for anything. Just package it within MCP functions, and then it could be part of MCP server. And that will make life so much easier for pen testers, right? So if you want, you don't need to do this stuff manually yourself. You could find them and you could work on fix them. Yes.
So the AI is basically taking the output from the Nmap and then just putting it to a way that you can understand it.
Exactly. So think about it that eventually these tools, the MCP server that's connected to the Nmap, they provide context to the LLM. So the LLM is calling them and taking that input and eventually producing that nice report that you saw at the very end.
It's fully like able to understand
Exactly. Exactly.
Yeah. Output.
And that's where the MCP comes handy. So this protocol, it will define the communication between the LLM in one side and the tools, in this case, the MCP server that will run Nmap, get the outcome, send it to this. Then what happened? LLM will understand it, decide what to do next, and call the next one fully autonomously.
So make sure they both speak the same language to each other.
Exactly. And that's exactly the problem that MCP has solved, is the standard exchange between those server and the LLM server. And this is why we are able this with very little effort. Very, very good point. Yes.
Can anything be done about social engineering?
Good question. Now, there are lots of tools out there that will produce fake email, even like this is part of training for organization. They usually like produce some phishing email and encourage employee to report them. And there are like some reward system out there. So if employees they are able to flag the correct one, they get rewarded and this stuff. But the problem is it's not easy, like, because the traditional training of what to spot has changed now. Now, in the example that I showed you earlier, whether it is mine or Harren's one, they look 100% genuine. There's no way you could train anyone really to doubt them. So you really need to use common sense in this aspect. And when you reply, you need to reply with care. And always, I think the best advice is always assume that this is a phishing email, even if it is not asking you for it. So you need to second guess. Training people is really the key. Anything automated doesn't work these days. Any kind of simple rules, they don't work. They work on the dear friend, I have few million pounds. That's they work there, but they don't work on the hyper personalized one. So being careful and watch what comes next. Because when they, usually what happens is you will be sent, say, a Word document to fill in. And this Word document might include a script. And you say that this is trusted, so you might trust the script. And once you activate it, or once you say, yes, go ahead, then you're probably giving these documents full control to your computer, and everything can happen then you have the layer of the setting, the least privileged setting when it comes to managing computers, like make sure that if you have admin account, don't use it. If you don't, you just use the normal one, even on your computer. You create an account with restricted privilege and use it all the time. So you can limit the damage and so on. I hope that answered like part of the questions.
Okay.
I
have a question, Ishan.
Sure.
Thank you for the fascinating presentation.
Pleasure.
But it seemed to be that the red team is always on the winning side. Am I correct or am I wrong? So if you actually have this game, you showed a very good demo.
Yeah.
But is it easy to actually using the LLM and any other software tools?
Yes.
Defend.
You can.
So, for example, to actually start to fighting against this red team's use of AI.
I mean, initially, I included some slides on the agentic AI for the defense. Then I thought would be too much, so I made focus on that. So there are some interesting work in that aspect. But you are absolutely right. Now, the problem, it is not fair game between the offensive side and the defensive side. The reason is because say you have a huge attack service, say you have 100 points of attack. The defensive team, they have to make sure they are all 100% secure. Whereas the offensive one, you only need one. You need one vulnerability and you are through. Whereas there, you don't have. So this is why they work together. And the best probably approach for organization is really to use ethical hacking and penetration testing. So it's not really an option now. You have to use them because these teams are trained to find the vulnerability in your system, and they are good. Really, they can find it before the bad guys, and then you can bridge it. That's where even the government is trying to really encourage more people to do it, and some of it is being even a legal requirement in terms of like protecting businesses. So you have to demonstrate that you have taken measures in place to protect. One of it is getting cyber essential. Another one for medium to big, you have to have penetration testing and other something you can demonstrate that you are really taking security seriously. Yes.
Have you found any situations where the LLM restricts a white hat tester trying to do pen testing?
All the time. So when I was preparing for my ethical hacking module that I teach, it was a bit hard to get some of this stuff done because I would say that's the so-called role playing, because I would say I am an instructor. I'm genuinely an instructor. I want to teach students. It was working, but nowadays they say sorry because now the problem is the black hat hacker, the cyber criminal, will say I am an instructor. And then they will say, I want to teach students, can you give me a code? So that's why it is, in addition to the probabilistic nature of LLM and why it is hard to control it, the problem is these resources are needed by both the pen tester or those who are working in education, as well as the hackers will need it too.
Have you thought of setting up a private LLM?
Myself? Maybe something in the future, but not at the moment. But there are actually needs for something specific for pen tester where it could. But the question is, how do you make sure 100% it doesn't fall in the wrong hands? That's another double distance.
You're the security expert.
Yeah, absolutely. Yes.
In terms of jailbreaking, do you think that AI companies are catching up and staying on track with it?
If you read about what they are doing, they have massive projects and they are spending so much money on safeguarding the AI and labeling and traffic system and so on. Even at Humble, I think you sent me an article about what AI is doing in the new year, right? About project around safeguarding this. But the problem is, again, unless the LLM, the way it's being trained is fundamentally different from what it is now, there's no way, because by nature, as I explained, the way it works, it is impossible to have 100% control over the jailbreaking problem. Because there will be always, no matter what you filter you add, you could always find a clever way to really go around it and get what you want. So that's still an issue. It's not.
Do you think that it will always be that way, or?
As I said, unless there is a completely different way to approach it. But again, back to the question, some of the things that I need as a cybersecurity professional or somebody working as a pen tester, I need LLM to help me with it, or Gen AI in general to help me with it. But the same, how can this agent know whether I am truly in need of this or pretending to be there? And just verifying everyone is a really hard problem. I can't see it in the near future solved. Even if they solve the way it works, it's still the problem, the need for both sides. So how do you solve it? Yes.
Just on the previous question, if you, let's say, the white hat hackers can create an LLM, likewise, the others could create their own private LLM. Just input to that. Do you think, let's say, not necessarily in the near future, but going forward, if we can't keep up with this kind of race between the two sides, could we look at the problem in a completely different way, in a sense, there's nothing really to protect?
That's an interesting approach that actually Google took when it comes to infrastructure, the zero trust infrastructure. Like you presume that everything is not trusted, even if you connect through VPN, whatever, there's zero trust and you act accordingly. So you could, in the future, have something like this, but eventually you are going to solve part of the problem, not fully, because here the problem, if I want to state it, is say that you have people with very little or no skills having access to advanced tools that they can really, these advanced tools can cause harms to other organizations.
But then you'd have your compensating controls in place. So, but use the example of NMAP, the
Yes.
support scan.
Yeah.
I know that I've got my Steam alert set up to pick up those support scans.
Sure.
So I think that it's kind of a two-way thing to look at it. Look,
Yeah.
The AI's got to have the understanding of the attack that it wants to do,
Mm-hmm.
but then as organisation, I've got my compensating controls in place. I'm putting all those juicy logs in
Yes.
to make sure that I can identify what's going on with that.
But that's the thing. I mean, if you look at the cybersecurity breach survey, like the percentage of organizations that do absolutely nothing in cybersecurity, it's absolutely scary. It's like you have 50% of businesses, they do absolutely nothing in relation to cybersecurity. So you're right in the sense, if you have somebody working on that, then it is going to be a fair game. But that's not an option.
This is where I think that I work for a fairly big organisation. We understand our whole supply chain.
Yes.
So we actually go into quite a lot of detail about actually what cybersecurity controls are in place all through the supply chain.
Absolutely, 100%.
It's kind of that kind of two-thing here.
Yes, yes. I mean, it's getting better now with even regulations in place. Like you have some contracts that you cannot get unless you have Cyber Essential or Cyber Essential Plus or some stuff in place, which is good. Although it's bare minimum, really, it doesn't do much. But it is.
Feels haven't been through Cyber Essentials Plus. It still feels like a little bit of a tick box.
Yes, it is. It is. But this, as I said, that's the minimum. That's the absolute minimum. But you would be surprised that even that absolute minimum, you have so many businesses that they don't have that bare minimum. Yes.
I've seen that like a lot of companies will have like a chat or bot for their help desk.
Yes.
And like instead of like the old way where they'd use dialogue tree, now using an LLM. And so hackers can just use prompt injection to get information out of the LLM that they're not supposed to. Do you think it'll ever be worth it for like companies to ever? Do you think it's actually worth it for the security for companies to use LLMs for the LLMs in their help desk?
That's actually an excellent point, because now you have companies, they are rushing really to have their own chatbots. And the problem is they give these chatbots access to sensitive information sometimes without realizing that it is sensitive, or without realizing that you have these major problems of jailbreaking and other attacks on those ones. So if it is deployed correctly and securely with really good understanding of what this chatbot can or cannot do, it will bring massive benefit to the business, right? Because it will give you tailored support, will make life easier in terms of, instead of giving you generic answers, signpost you in the right direction very, very quickly. So this is why when it comes to that racing car and the cybersecurity professional, they have to be together. So if we have security by design, when we design this, we are fully aware of what you are saying, then it might not be as fancy and probably access everything. It will be a little bit more restrictive, but it will be more secure. So it's always like the convenience versus security kind of balance. Like more you give it, you open new door and probably access to others. So I won't say they're bad 100%. I would say not great. And so it is all about how do you deploy them, whether it is secure deployment, proper deployment, person who's working or the team are fully aware of what can be done. And that's the awareness factor that I started my talk about. Yes.
If you don't mind, I'd like to add something to that to support you. I think one of the challenges is the use of these standard products in chatbots, whereas properly engineered systems that use the APIs stand a much better chance of achieving what you just described.
Absolutely, absolutely. But this will come at cost, right? So that's
well, yeah, but it's always the cost between product and service solution.
Yes,
and with the product you
so those making a decision, unless they are fully aware, fully informed, probably they will opt for the easier, less secure option, cheaper option, I would say. But if they are really fully informed and they know what they're doing, they probably use to be more.
Knowing what they're doing is very rare.
True. Yes.
What about VPNs?
Yes.
And also rogue VPNs, which are harvesting data.
So, as I said when Harin asked the question, now the model, the cloud model, because so many organizations, they're moving their businesses, services, etc. to the cloud. There are some interesting solutions like the Google Zero Trust solution, whereby it will assume nothing is secure. So it will add layers of security at every point. So the older fashion, which still works actually, so you have pretty much two models. One where if you have a business and you have most of the work within the organization, within say the university offices, whatever. So if you want to access, you call in through from home or whatever to particular server, you go through the VPN. So it will provide extra layers of protection. So if it is trusted VPN, then it's always added value of connecting through VPNs. Of course, are all VPNs trusted? No, obviously not. Some of them they will say they don't collect any data. They are sessionless. They are whatever what they can claim. But can you really be 100% sure that this is the case? That's another question.
Okay, I think we're nearly exhausting the online so the venue question. I'll just go through some of the chat points that are not yet addressed. Dave Hodgson was making the comment around wondering how to achieve by design automatically.
That's a very good question. I mean, it's not going to be autonomous by design in the way that probably you might think about it. Like it just like you need people who are fully aware, whether they are coder, whether they are tester, whether they are deploying these Gen AI system, they need to be fully aware of the security implications of what they are doing. I remember from my old days when I built my first website, it was hacked in 2 hours because I didn't know anything about SQL injection. Then I learned the lesson. So it was fully functional, and that's the trick. It's from fully functional in terms of accuracy to fully secure. So you need people when they design, when they first think about something in the first place, how do you build it securely from the first place?
Brilliant. So there's a follow-on point from Mary Hopkins too. She says, it looks as though LLMs and AI won't solve the problems of fuzzy health. So I think it's probably a people health EPR data. I don't know what EPR is.
Health, fuzzy health. Can you, if who's ever asking, can you please elaborate on this? I didn't get really the question. You can take the next question, and if they want to come back.
Yeah, so I'll just move to the next one. Heiko asked whether there are standards or best practices for this topic that include prescriptive security control?
I mean, there are some good resources on how do you design when it comes to agentic AI. How do you design AI agents securely? I think OpenAI, they have published something about it. Google, they have published something about it. So there are plenty of resources to look after the security. But the thing is, I mean, here it's all about the context. You cannot get a solution and apply it as is. So you really need to understand the context of the business and what is this AI tool doing exactly, what access does it have, and so on, and design accordingly. So those will help those guidelines that I mentioned by the leading Gen AI providers, but you also need to take business context into account. It's more important.
Yeah, that's great. So may we have a second question? When AI has detected a security risk, can it fix it, or does that need human intervention? What happens if the risk is a hallucination?
That's a very good point. I mean, that's where you have the so-called purple team. So we've been talking about all the time the red team and the blue team. So the purple team, this is the team where they work together, actually. So you have these AI tools like this, or people using their own skills with AI tool to find vulnerability. That's the first place. And then you have another team or an extension of that team that will be able to bridge. Because the difficulty in finding the problem, solving it, is not really that difficult. Or at least when tested, they don't care. Just find it and somebody else will fix it. Because that's how it works.
Brilliant. So I think we've exhausted the questions online already. So because of time, I just want to close the session by thanking Hisham for the excellent presentation and our host who look after us here today. Thank you very much.
Send my thanks to Pam and Humble for organizing this session. So thank you very much.